All right, so today, okay, good, just making sure we're at the right spot. We're going to start with multiplying and dividing with the negative fractions. The great thing about multiplying and dividing is no common denominator is necessary. So that's often a mistake I see, especially after we're done with adding and subtracting, is students seem to think they need a common denominator before they multiply. Not the case. And it's actually much harder if you do that and much more work. All you need to do is make sure you have two fractions. So negative 2 is not a fraction right now, so we need to make that into 1. And if you remember, we do that by putting it over 1. Then it's really simple. We just multiply across the top and bottom. So across the top here, negative 2 times 10, negative 20. Across the bottom, 1 times 7, 7. So we times our numerators, we times our denominators. Use that academic vocab. Okay? And then lastly, we look, can it be simplified? My answer here is no. So this is my answer. It lets me circle it. There it goes. And you could also have negative 2 and 6/7. That is also an acceptable answer on that one. All right, two fractions set up, multiply the numerators, multiply the denominators, straight across. Now, often I saw on the pretest a lot of cross multiplying. That is not what you do here. Cross multiplying only occurs when there's an equal sign between the numbers. So if I had something like this, then you would cross multiply, and the reason you do that is it helps you figure out this answer without finding a common denominator. So 5 times 1 is 5, 4 times x is just 4 times x. And then you use one-step equations where to get rid of that 4, you need to divide by 4, because that'll equal 1, but then you have to divide by 4 here. So that the x is 5/4. We'll be doing that later in the year, so just kind of a little preview. But the point of the segue was to show you only cross multiply if there's an equal sign in between. So that's the difference. Is there an equal sign or is there a multiplication sign? And remember, the dot means multiplication. All right. So here, multiplying straight across the numerators, straight across the denominators. 1 times a negative 2, remember that negative goes with the top, is negative 2. And then 3 times 9 is 27. Another common mistake I see is people taking that negative to both the 9 and the 2. You don't want to do that because that negative doesn't occur twice. It only occurs once. So it only goes with one of those numbers. And it is common, actually it's proper to put it with the top number. Again, we simplify, negative 2 over 27. 27's odd, so there's nothing we can do. And it is a proper fraction, so that would be our only answer there. Alrighty. Double negatives here, so we've got negative 7 times negative 2. It's a positive 14. 9 times 9, 81. Looking to see if I can simplify, and I cannot, so this is my final answer. Multiplication is really nice. It's one of my favorite things because it's just straight. And hopefully I've got a couple problems in here I can show you as we go that you can simplify at the end like I've been looking for, or you can even simplify as you go. It's my favorite. It makes that end work so much easier. All right. Mixed numbers. So remember, I like to change it first, and especially with multiplication, you generally have to do that. Because if you can't really combine the whole number parts and the fractional parts, you won't get the right answer. So 8 times 4 is 32, plus 5 is 37 over 8, times negative 3 over 1. So I'm just looking here. I can't do any simplifying beforehand anyway. So again, across the top, those numerators, and then the denominators. So that's 21, carry the 2, 9, 10, 11, negative 111 over 8. And I already looked to see if I could simplify before, and I couldn't. Otherwise, you would look at this step. Can I simplify? The answer is no. They're not both even, so we can't divide by 2. 4 doesn't fit, and definitely not. So final answer is negative 111 over 8. Or, trying to think. Is 13 going to be too big? Doing this all in my head, guys, here, so bear with me. 104, yep, it's got to be 13. Or negative 13 and 7/8. Big number there. But don't feel like you have to change it into mixed fraction. I'm okay if you leave it improper. My biggest part is, can you do the multiplying correctly? Can you do the simplifying? It's great if you can change it back into a mixed number. So if you can, go ahead, do it. You guys are far enough ahead, you can do that. But I'm not requiring it. All right, first step, change it. Remember that negative gets added at the end when we change. So 8 times 3, 24, plus 5 is 29. Add the negative. Times 1/2. Again, I'm not seeing anything I can simplify beforehand. If I don't find one when I'm done with these examples, I'll come up with one for you. So negative 29 over 16. I told you, can't simplify ahead of time, so that's my answer. Or negative 1 and 13 over 16. That would be right as well. All right. Negative 9 times 3, 27, plus 7, 34, so negative 34 over 9. 6 times 1 is 6, plus 5 is 11. 11 over 6, and times. Hey guys, I found one where you can simplify beforehand. This is called, well, I don't know if it actually has a fancy name, but it's canceling, simplifying first. So when you multiply, remember, everything switched around is still the same. So 5 times 3 is the same as 3 times 5, right? So with fractions, I could do negative 34 times negative 11, or I could do negative 11 over 34. So essentially, those top numbers can be switchable. Same with the bottom. And with that theory, anything in the top could cancel with anything in the bottom. So you may notice, or maybe you haven't, maybe you already know this, maybe you don't. Both 34 and 6 are even. So yes, they're not on the same line, but like I told you, anything with the top can cancel with anything in the bottom. Now you can't cancel if it's on the same side, but you can cancel if it's on the opposite. So since they're both even, we can divide the top by 2, essentially, and the bottom by 2, right? I'm just applying it to one number instead of the whole thing. So this becomes negative 17, and the 6 becomes a 3. And now I continue with my multiplication problem, because there's nothing else I can take out. And instead of negative 34 times negative 11, which is huge, I just do negative 11 times negative 17. 170 plus 17, 187, positive. And then on the bottom, just 9 times 3. And I already simplified by canceling those out to begin with, so I know my answer is in its simplest form. Which would be, or, how many times does 27 go into 187? Round that to 30, round to 190, 1, 2, 3, 4, 5, 6 about. 12 plus 4, 162. I'll give you one more. Dang. 27, 9, nope, I'm wrong. Only 6. So 6 and 25 over 27. If this cross-canceling beforehand stuff is confusing for you, then you just go back. Multiply cross like normal. Yeah, 54, 340 plus 34, so negative 374, I think. Yeah. So huge numbers, you notice they're both even, so we're going to divide by 2, which should get you back, oh wait, something I just noticed, sorry. That 374 is positive. Anyway, you simplify, you're going to end up back to what I got earlier, 187 over 27. But you had to do it with these huge numbers, whereas what we did up top earlier was we simplified before timesing. So it's simplifying ahead of time. I like that method. All right, looks like we're moving into division. All right. So again, with division, you need 2 fractions. On pretest, I saw a lot of cross dividing, a lot of dividing straight across. No, with fractions, what you're doing is you're splitting one fraction into an even smaller fraction. So it's very, I don't know how they came up with this method actually, but anyway, it's leave, change, flip is the one you guys will learn today. So you leave this first number alone. So negative 3 over 1 stays. You change the division sign to multiplication. And then you flip the last fraction, so 7 over 1. So in this case, now we have a multiplication problem, so we can just do our numerators and our denominators. 3 times 7, negative 21. 1 times 1 is 1. So your answer is negative 21. Should be familiar. You did learn this last year, the year before, with flipping. You also probably learned proportions, which is why a lot of you have that cross multiplication in your head. But no. Leave, change, flip. So leave, change, flip. Again, you can take that negative and keep it up top. Even though we flip the fraction, keep it up top. You make your life easier. If you moved it to the bottom, it's okay. It'll just, you'll end up dividing a negative by a negative at the end, which is a positive. So I don't know if you noticed it here, but now it's multiplication. I could cross cancel. 9 over 9 will end up being 1. So those can cancel. Divide them both by 9. And all I'm left with is 7. Remember, this is still negative times a negative. So it's a positive 7 over positive 5, which is 1 2/5. Either one. Right? Now again, if you put the negative on the bottom, you end up with negative 7 over negative 5. Negative divided by a negative is a positive. Never leave 2 negatives. You should only have 1 if you're going to have one. You have 1 or none. And I do want to reiterate how to do this if you didn't cross cancel beforehand. Right? Numerators, denominators times straight across. Positive 63 over positive 45. You have to simplify down. Divide by 9 or divide by 3 twice. And again, you should end up back here to 7 over 5. There's a couple different methods here. Look at how all the work we save by cross-canceling beforehand. It's a new skill. I don't know if anyone's ever taught you that. If they have, you'll be great at this. If not, use it. It makes life faster. All right, this problem's a little weird, but they do happen. It's a fraction within a fraction. And all a fraction really is, though, is dividing. You just have to identify where that fraction piece actually is. So this problem is actually 2 divided by -3/5. So option 1 of solving this is rewrite it and solve it just like we have in the past. So 2 over 1 stays. Change, flip my fraction, and keep the negative up top. -10 over 3, or -3 1/3. Now, there is another method that I want to show you. One of my parents helped me learn this last year. I guess they do it in Venezuela. It's called the Deep Blue Sea. Don't know why they named it that. Not really sure. So in this, you keep it as a big fraction, but you have to still change the whole number into a mixed fraction. And with it, then you do times the insides times the outsides. So 1 times -3 is -3. 2 times 5 is 10. Where people usually get stuck is they don't remember which one goes on top and which one goes on bottom. So you work outside in. So it's 10 over -3. The negative's on the bottom, so it'd be better if you moved it to the top, but it's not completely incorrect. And then, of course, if you like to, the mixed fraction. So that's the Deep Blue Sea method. A lot of my 7th graders used that last year. It's the only way they can divide. Okay, so set up like that Deep Blue Sea. So I'm going to start with that way. 3 times 3, 9. -1 times 5, -5. Be careful. See how I grouped that with that top? Don't do it twice. And then remember, outside in, -5 over 9. Simplified, so that's my answer. Kind of stinky part about that Deep Blue Sea method is I think it's harder to cross cancel, which remember when you change multiplication or division problems to multiplication, there's always that possibility of canceling before or simplifying before you reach the end. So the other way, remember this is my division line. So that's -1/3 divided by -3/5. And we leave, change division to multiplication, flip the fraction. Now in this case we can't cross cancel, but I didn't know that until I flipped it. -1 times -5. +5. Mrs. U-Haul did a boo-boo up here. Well, maybe you caught me. 3 times the -3 is -9. -5 over -9 is that +5 over 9. So you should never leave it like the negative over negative. Oops. Well, we caught it. That's the important part. So if you did this method down here, maybe it would have been easier to catch. Anyway, back to this. Then you do 3 times 3. That's 9. Now simplifying, so that's my answer. All right, mixed fractions. Just like with multiplication, you have to change these for division, otherwise it doesn't work. 8 times 2, 16, plus 7, 23. So -23 over 8 divided by 4 times 1 is 4, plus 3, 7. Oopsies, that's not 3, that's 4. I have to do it again. And it is negative, that goes up top. Okay, leave the first fraction alone. Change division to multiplication. Flip the next fraction. Okay, I'm trying to look and see if I can cancel beforehand, and I actually can. You can divide 8 by 2, you get 4. Oh, wait, even better. Hold on. Even better than 2, I can go bigger. Divide 8 by 4, and I get 2. divide negative 4 by 4, I get negative 1. So up top, now all I have is negative 23 times negative 1, positive 23, and the bottom, 2 times 7 is 14, or 1 and 9/14. And again, if you didn't cancel beforehand, and simplify first, you can just simplify at the end. So 23 times 4 is a positive 92 over 56. Now I know we ended up dividing by 4, but if I was looking at this, I wouldn't necessarily know 4 goes into it, to both of them. So I probably just start with 2 myself. If you did know 4 goes into them both, great. You can just skip straight to the end. I, unfortunately, am going to be dividing by 2 twice until I get to a point where it can't be simplified. Looks like I've got 3 more questions on here. I didn't know I had so many. Sorry, guys. If you think you got it, pause this video anytime. Okay. Round the clock. 3 times 1 is 3, plus 1 is 4. Remember, when changing mixed numbers with negatives, it's the same as if they were positive. You just have to add the negative at the end. 10 times 3, 30, plus 3, 33 over 10, negative. Can't forget that. And of course, we have a division problem. All right, leave, change, flip. Both my even numbers are at top, so I can't actually cancel anything. Because 4 and 10, I can't cancel because remember, they're both on the same level. They have to be opposites. So I actually don't see anything I can simplify. So my final answer won't end up needing to be simplified either. Numerators, negative 4 times 10, negative 40. 3 times negative 33, negative 99. Something I just noticed that maybe you've been doing too. When I flipped it, I moved that negative to the bottom. That's okay. If you forget to keep it, that's fine. But what you'll notice here at the end is now I've got a negative divided by a negative. You cannot leave it like that. You have to then change that to 40 positive over a positive. Remember, the whole thing is just positive. And so that would be my final answer. All right, you can do this deep blue sea method, but again, you got to change it first here. So change 3 times 2, 6, plus 2 is 8. So negative 8/3 all over 6 times 3, 18, plus 5, 23. So again, harder to simplify this way. 23 times, simplify ahead of time, I guess I should say. 23 times 3, 69. Negative 8 times 6, negative 48. Remember, outside in. Negative 48 over 69. Trying to think. I think 3 goes into these. So divide top and bottom by 3. Negative 16 over 23. I think that's my final. Now for you who like to do it the other way. Again, you still have to change this into these 2 improper fractions here. But then we can rewrite it. Negative 8/3 divided by 23 over 6. And maybe you did a step before that. Maybe you rewrote it as negative 2 2/3 divided by 3 and 5/6. And then made them improper. Either way, it doesn't really matter. Whatever works best for you. Leave, change, and flip. So if you recall, I ended up simplifying by 3. You can again do that at the end here. Or you can notice the 3 would simplify to 1 and the 6 would go to 2, right? If I divide 6 by 3, I get 2. Divide 3 by 3, that's 1. And then on top, I'm left with negative 8 times 2, negative 16. And 1 times 23. And beforehand, it's great. Otherwise, if you didn't cancel it beforehand, you'd multiply straight across and end up where we did with that other method first. And then have to simplify it. All right, last one. Yes. All right, it's around the clock. Negative 19 over 10. 64 over 7. Hopefully you got that. 10 times 1 plus 9. 7 times 9 plus 1. And if you were to write it that other way, negative 19 over 10 divided by 64 over 7. All right. Deep blue sea, insides, outsides. Ooh, that's nasty. 10 times 64 is 640. 19, negative 19 times 7, negative, carry the 6, 133 outside in, so negative 133 over 640. Yikes. Hope that's not our final answer, but let's see. They're both not even, so I can't divide by 2. 3 doesn't come out of evenly out of 133. 4? Nope. 4 won't work. 5 doesn't, it's not odd. 6 won't work because 2 and 3 didn't work. 7. Nope. I wonder if that's it. I'm going to cheat here and look at my calculator because I've just gone through a ton of prime numbers and it didn't work. Nope. That is the simplified answer, you guys. Icky. So that is my final answer on that. You do it this way, leave, remember, change, and flip. By the way, you'll see me alternate between the time sign and the dot. It's kind of just habit, I do both. So then on top, you should get that negative 133, and on bottom, 640. Icky. But sometimes that happens. That's why you've got that blue calculator if you need it. You guys are smart enough. You can all do it by hand, though. I know that. All right. If you have any other questions, let me know. I will be handing back homework hopefully soon. And remember, you can always look up more videos if you need help as well, or maybe you want a different method to solving these. And stop.